I'm Mitch Marks, and this is my poster session on accurate measurement of EV range. So today we're going to be looking at how do we determine what the range of an electric vehicle is. When we go to purchase an electric car, we have a given range, so the number of kilometers it can go, as well as what the miles or kilometers per gallon equivalent electrical is. And how do we determine these values? So if we look at what we call a certification test, the test where we get the stamp for this range and for this miles per gallon electrical equivalent, we're going to run the vehicle on a chassis dynamometer, which is basically we take a car, we put it on a treadmill, and we're going to run it through a series of drive cycles. We can see these drive cycles here. And what these drive cycles are is speeds versus time for different accelerations, for different speeds, for different city, highway conditions. And this is going to tell us how far can my car go in city, how far can my car go in highway. And in this certification test, we're going to start with the vehicle having a full battery, and we're going to run that vehicle from full to empty through this series of different drive cycles. And we're going to run these at city, at highway, and look at the different conditions. Now this is for certification, and when we're measuring for certification, we're going to take one measurement on the DC bus. So we're going to instrument the current and voltage of the DC bus. We're going to look at power consumption throughout the drive cycles. And we're not only going to look at power, but we're also going to calculate energy from it. And this presents a very interesting measurement challenge because the accuracy of this measurement really matters. If we take these drive cycles and we calculate a 300 kilometer range, but we have a 1% measurement uncertainty, 1% of 300 is 3 kilometers, we can only publish a 297 kilometer range. So by measuring that measurement uncertainty, we can actually increase our range. So that's really cool. So that's the drive cycles, these series of speeds versus time that we're going to run the vehicle through. Now you don't just take the vehicle to the big show. You want to calibrate the vehicle first. You want to determine the good components, the bad components, and make changes so you can maximize that range. So this is what we call the engineering range test. Now the engineering range test is going to be the exact same as the certification test, except now we're going to instrument every possible power sink in the vehicle. We're going to look at the heating, the cooling, the battery temperature regulation, the infotainment. We're going to look at how each component consumes electricity throughout these drive cycles. And we're going to do this over the exact same situations that we do the certification test. So we're going to run through the different city and highway drive cycles. But then we're also going to measure the power. And we're going to look at when we reset through each scenario, so we can look at what is the highway mileage, what is the city mileage. And we're going to calculate energy through each one of these segments. So this is really cool. We can actually understand what the energy consumption for each component for each segment is. And if we have a good component, we can keep it. If we have a bad component, we can change it. If we have an inefficiency between front and rear powertrain or powertrain and climate control, we can augment that higher level control strategy to get the best range possible. So that's the engineering range test. And in that engineering range test, we're really maximizing that range for certification. Now the last test is the component level range test. And the component level range test is also very critical. These are going to take the individual components, maybe the powertrain, like in my example down here, where we have an electric motor inverter attached to a dynamometer. And we're going to run that motor inverter combo through the exact same drive cycle that we would for our certification or our engineering range test. Now the cool thing is with HBK equipment, we were able to do this, is we were able to look at what the individual acceleration and deceleration power levels were. Because we use a system called cycle detect, and up here we can see I have this red sine wave and this black square wave that's indicating it. And we're looking at that sine wave, we're identifying zero crossings, and we're using those zero cross periods to calculate power. So every half cycle of the fundamental, we're getting a power measurement. So we can understand what our power and energy usage is as we're accelerating, as we're decelerating, in these drive cycle-like conditions where we are simulating that real world. So on our component level range test, we're able to run the exact same drive cycles. We're able to look at cycle by cycle what the energy consumption was. And then once we understand, am I lossier at this point? Am I more efficient at this point? We can change that component level architecture. We can maximize the efficiency of that component. We can take these maximized efficiency components and bring them back to our engineering range test. We can maximize that vehicle range, and then we can go to the certification test. This is going to allow us to get the maximum range possible. So in conclusion, to get vehicle range, we need to run a certification test. To get the best range in that certification, we need to optimize the system in an engineering range test, where we run the vehicle through a series of drive cycles. And then lastly, to maximize the range, we need to optimize our components. And through this component range test, we're able to maximize our range. For any questions, please feel free to reach out to me. Again, my name is Mitch Marks with HBK. Thank you for your time.